Good evening, everyone. Welcome to the 104th video. I think it's 104. Yeah, 104th video on the misconceptions in physics video series. My name is Ratankar Rao. I teach physics in an international school in Bangalore, and my passion is to teach physics. I like physics a lot, in particular sciences. Okay. So the videos that you observe or that you view here are a result of a series of meetings that we had with my alumni and as well as my students, wherein they all opined saying that it is not the concepts or the derivations that are important for a student to do well in physics, but while an understanding about what mistakes he does and why does he commit this mistake. So towards this video series has been thought of. So several students do write an email to me saying that these are the mistakes that they are experiencing, even though upon learning the subject appropriately from various resources, textbooks, and so on, they commit a mistake. Then my work is to analyze that mistake. Why did they do it? Usually, what happens is we will have one concept, and if we have two contexts, so we need to know about under what context should we use which concept. Okay, so this is something which the students are not able to analyze it, and this is the work I do. And basically, I'm a researcher, and my interest is to research and all this. So research being a passion, that's what I actually do it. I continue with it. Okay, so now let me continue. Let me share my screen of today's lecture on. Okay, so this is my contact number. I can be reached through WhatsApp or through Telegram. And I am on my, if you want to view all my video lectures, you will be able to see it under this website, ratankar.com. So every day, sharply at 7 p.m., a video will be broadcasted on YouTube. And maybe 8:30 or 9 p.m., you'll be able to see the same video in LinkedIn, Facebook, Twitter, Reddit, or into my website also. Okay, so this is how it has been organized. And today's topic of interest, we've been working on forces. Earlier, we used to work on several other topics. And today's interest is forces. And well, the topic here is about the throwing force is equal to the weight of the object. So the main concept here is about understanding the Newton's laws of motion, or laws of motion in general, or understanding the forces, how to apply forces, and so on. Okay. Now towards it, let us read this question. Usually my videos will have three important parts. The first part is about understanding the numerical completely. And second part is about the student response when the student writes an answer and he gets it as incorrectly. Now he writes back to me saying that this is what I have written. So what is incorrect here? My reasoning is appropriate. According to him, it's appropriate. Okay, so that particular solution, a little bit here and there, I refine it and I put it across here. Because when he writes, he will not be writing the whole thing in an appropriate way. So I just understand from what he writes, and then I coin that this could be the concept that he has understood, which should not have been applied here because the context is different. And then finally, I'll give you the solution. This is what it is. Okay, so a man holds a ball of mass 1 kg in his hand. So I hold a ball of mass 1 kg in his hand. He throws it vertically upwards. I throw it vertically upwards. During this process, its hand moves by 40 centimeters. So which means I have a ball like this. I throw it upwards like this. I'm lifting my hand by 40 centimeters. It means I'm not throwing it instantly here. My ball is not being thrown instantly here, but it is being thrown over here. The distance between the point of contact and the point of raising, the moment I leave it, okay, this is seen to be 40 centimeters. This is known to me. And then with an upward velocity of 4 meters per second. Now, when it reaches here, it is moving at a speed of 4 meters per second. What was the speed at this point? It was 0 meters per second, right? Because I started from here and I started moving upwards. And then the constant force at which the man pushes the ball is, what is the force at which I push the ball? This is the question here. Now towards it, the student response is, when we throw a ball, we give a kinetic energy to it, but not the force. Okay, so when you throw it, obviously, that's right. Okay, we do not give a force, we actually give a kinetic energy. The moment the ball leaves our fingers, the moment it leaves our fingers, it will have a constant downward force, okay, which is nothing but equal to mass multiplied by gravity, because the moment it leaves my fingers, there is no force acting on it by me. It's only the mg force which is acting. And then by NLM, it should be the same force which our fingers should have given the ball. Now, what does NLM state? Action and reaction are equal and opposite. What is the action according to him? According to him is nothing but, you see that there's a force which is acting on it, which is the gravity force. And the same force should have also acted here. Okay, who is the cause? Who is the effect? That's the question we need to ask, right? Now, the cause is the particle goes upwards because I have pushed it. The effect is the gravity. Not the gravity, the particle moves upwards. But here, in a particle, when the particle leaves my fingers, gravity is acting. Now, will this gravity come back to me? It doesn't, right? So therefore, this is a misconception. So which means the student has not properly understood the Newton's third law of motion. Okay, so somewhere, so physics, people generally teach everything correctly. We all teach things correctly. But the only thing is when it comes to a context, we need to understand the context appropriately. Okay, now let us solve this problem. The second, now how do we solve this? Now when you have the particle here, when you have the ball here, its velocity was 0. And when you lift it upwards by 40 centimeter, okay, its velocity was 4 meter per second, which means this could be your initial velocity. This could be your final velocity. Now it has moved by a distance s over here, which means, and once again you see the constant force that is acting, which means what? He is not lifting something like it started from here, slowly lifts here, and then he looks at here and there, and finally he lifts it once again, and once again, oh my pen, okay, I'm not going to throw it. He doesn't keep like this and then lift it upwards. He doesn't do like this. He says, okay, I'm going to throw this ball from here, throw it like this, with a constant force I'm applying here, right? When I say a constant force, that means when I say force is equal to a constant, your acceleration is also equal to a constant. Your acceleration is also equal to a constant. When the acceleration equal to constant, what do you get? You can say, I will apply my equations of motion. Right? Now, which equation can you apply? See, V is given, S is given, U is given. I hope you would have guessed by now. It is none other than V square is equal to U square plus 2AS. Right? So, now what do you get from here? You get the value of A. Now, what is V? 4. 4 square is 16. What is U? 0 plus 2 into A. I do not know. Yes, sir. What is S? 40 centimeter. And it is 0.4 because I need to convert it to meters, not centimeter. So, thus, I can now write from here as 16 is equal to 0.8A, or A should be equal to 16 divided by 0.8. What's the answer? 8 ones are, 8 twos are, then 2 divided by 0.1 will be 20 meter per second square. Now, what is this? The acceleration of the ball when it is in my hand, when it is about to be thrown. It is not in air, it is about to be thrown. Now, I need to find the mass. What is the mass? Mass of it is 1 kg. So, therefore, the force that will be applied, okay, the moment it is being thrown outwards is nothing but mass multiplied by this acceleration. Do not consider the value of G until and unless it is leaving your hand. The moment it leaves your hand, it is out of your contact. Then comes the value of G. Okay, which he has answered it correctly. It will have a constant downward force. This part is right. But the moment when it comes to NLM, he made a mistake. And finally, he said that, see, NLM comes into, and the same force is exerted here. Okay, so gravity does not exert a force on my finger, right? Okay, so therefore, now the answer is M into A, and the value of M is 1 kg multiplied by A is 20. Thus, the answer is 20 Newton. Okay, so I hope you have understood or got to know about the problem clearly. So if you have any more questions, you can always write back to me. The several questions every day, I get around 4 to 5 mails saying that this is the problem that I face. Okay, so thank you, friends, for watching this video until the end, and do share this video with your other friends. It's completely free. Okay, and so that it will be benefited across the globe. I have students from various parts of the country, and some of them are even from the abroad also, like US, UK, and so on. So might be, okay, this is not focused on one particular course like JE mains or advanced and so on. And I'm not going to teach anything like, what you call it, derivations, no concepts, nothing. I assume that you guys know everything about the concepts. And then I look at only your mistakes, pinpoint where you have made a mistake and why you shouldn't do it. and finally conclude with the correct solution. That's what my aim is. Okay. So therefore, so do share it with your friends. This is not a substitution. Somebody asked me, so can I just look into it and pass JE? You definitely cannot. Okay. For JE, you need to have a separate kind of training, which maybe you can enroll under me, or maybe you can study somewhere else also. But this one is completely free. I do not charge anything for this. You can have a look at it where you are doing a mistake. And if you are doing a course somewhere else and you do a mistake, do send me that question as well as the mistake that you have done, so that I can analyze where you have gone wrong and finally present it across. If you want, I can put your name also. This student from such and such place has sent me this and so on. If you don't wish to do it, it's well and fine. I'm not going to name anybody here. Okay, thank you friends for watching this video, and share and subscribe to my channel for further updates.